So I just completed a review of the last week of support cases, and I've determined that the AI that the support team is relying on kind of needs some sort of like reinforcement of what not to say.
Okay. Yeah.
It is repeating shit.
Yeah.
They've and now it is repeating shit. Developers are writing
split it into three parts. Quick primer on how LLM actually work, the theory, and some practice of vibe coding. That is the main topic. And a case study about the project we did called Red Team Coin. There will be some stickers available. Our goal is for you to live with a concrete framework for using AI safely, effectively. If you ever touch AI coding tools and feel like output was hit or miss, this talk will give you a better expectations about the tools. Want to go to this?
Sure, a quick roadmap. We'll move through this roughly in this part order. Parts 1 and 2 are foundational. If you already know how LLMs work, this will be a fast refresh. Part 3 is where the practical content lives, the structured framework, the craft of writing good prompts, and guardrails. And part 4 connects everything to how AI tools are actually configured in practice. The case study at the end ties everything together with how we created Red Team Coin.
Part 1, before we talk about how to use LLMs, we will be spending a few minutes on what actually they are. A lot of the failures we see later on will come directly from misunderstanding of these foundations.
AI is not a database you query for facts. It is a model that produces the most statistically plausible continuation of your input. If you give it a vague prompt, it will produce a vague but plausible sounding answer. This is not a bug, it is a feature. Thanks to Ram Kumar of the MS AI Red Team for that. Training happens once, hugely expensive. You interact with the already trained model at inference time. You cannot change what it knows just by prompting it.
Most people only ever see the user prompt layer, but that what controls AI tool behavior is mostly the metadata, the meta prompt, the system prompt, which never you write yourself. There are some exceptions for system prompt, but usually you don't. When ChatGPT refuses something or Claude responds with certain tone, that is the meta prompt at work. It's not just the LLM. There is the guardrails that we will explain later. When you configure your own tool like Claude Code, you own the system prompt layer. That is powerful. When prompt engineering is not just about writing the better questions, it's about structuring all the layers intentionally.
Each row in this table is a common misconception that leads people to misuse LLMs. Let's go through this table. We will go through what people think and what is actually happening, starting with the second entry to save time. It remembers the last time. It doesn't. Every session starts from 0 unless you explicitly feed it prior context. This is why long sessions degrade. It understands intent. It doesn't understand anything. It matches your words to patterns in training data and generates the most probable response. Hallucinations are architecturally inevitable. This isn't a quality problem vendors will fix. It is a fundamental property of the technology. The fix is verification, not trust.
Any questions so far? Anybody? Everything starts with the breadth of training data. The model has processed more code than any human team could ever see, conveying every language, framework, and idiom imaginable. Same goes with text and literature. This means that scaffolding Go, RPC, or writing PyTest fixtures, debugging Kubernetes manifest with roughly equal competence. But that competence is pattern-based. If your use is unusual, then you might need to verify facts. It will still hallucinate confidently, so frame it practically. Use it to accelerate. Let it handle scaffolding, test, reviews, and repetitive tasks. Just ensure you keep your own judgment on the loop to guarantee the correctness.
Part 2 covers something that trips up even the most experienced AI users, the context window. Understanding this explains most of the quality problems people run into with longer sessions.
So everything cost in the system prompt, chat history, files you paste in, any tool output, it all competes for the same fixed budget, the context window. The context window fills up. Two things can happen. Older content gets dropped silently. The model effectively forgets it, basically. Or the model starts producing lower quality output as it struggles to attend to everything. Anthropic and others have benchmarked this, calling it content rot. As tokens count increases, the model's ability to accurately recall information from what the context measurably decreases. This is why a 20-turn vibe coding session where you keep pasting error logs is actively degrading the quality of the AI responses by the end, not because the model is confused, but because its attention is spread across too many tokens. The fix: start fresh session for subtasks, keep context lean and focused. The n-square explanation is the next slide, and the audience may read the table, right? This is what happens.
This is the architectural reason for context rot. In a transformer, every token in the context attends to every other token. That n-squared pairwise comparisons here, where n is the total number of tokens, the table makes the scale visceral. A 100,000 context doesn't mean the model is doing 100,000 units of work. It's doing 10 billion attention operations. Quadratic growth is brutal. Doubling your context from 10K to 20K doesn't double the attention load, it quadruples it. This is why quality starts degrading well before the hard limit. The model's attention is spread thinner and thinner across an exponentially growing relationship graph. Practical implications for vibe coding: passing a 50,000 token code base isn't adding tokens, it's multiplying the attention load. Focused, relevant context is always better than large, comprehensive context.
Any questions? This is
a very important statement that we will be going over later on.
Yeah, because every token, it feeds backwards as well. So you keep context, and the output doesn't show random words one after the other. And this is key. Tokens are the unit of cost, latency, and quality simultaneously. This table gives you a good feel for scale of tokens. A full technical design doc, roughly at 10 to 20,000 tokens, is a significant chunk of even a large context window. The passing a large code base row in the one that you should really stand out to you. Many developers pass the entire files or repositories and don't realize how much context budget they are burning. For API users, every token and out cost is basically money. Prompt bloat is directly financial inefficiency. For every token, noise equals to basically more model noise, and more noise basically degrades the quality of the output.
Llama 4 Scout leads at 10 million tokens, a staggering number that shows how quickly the spec sheet has moved. Gemini 1.5 Pro holds about at 2 million tokens max, and the newer Gemini 2.0 Flash and 2.5 Pro sit at 1 million alongside GPT 4.1 and Llama 4 Maverick. Claude 4 Opus and Sonnet hold at 200,000 tokens, a practical sweet spot for most development workflows. GPT 3.5 at 16,000 is a reminder of how fast this space has moved. That was the frontier just a couple of years ago. The key point is not who wins the spec sheet. A model with a 10 million token window does not give you 10 million tokens of reliable attention. Quality degrades the further information sits from the edges of the context. Know your model's limit, but don't treat a large window as a license to dump everything in. This is a huge mistake most people make.
And if you go 1 second back, so if you remember at the times of ChatGPT 3.5, with this context window, you were targeting to create functions, and today we have models that can create entire files, multiple files at the time. And this is a big, big jump.
This slide explains why a vibe coding session that starts strong gets worse as it goes on. It's not the model getting tired, it's the structural property of how transformers work. Here's the most common mistake. Let me paste everything and ask it to keep it all in mind. It feels thorough, but actively hurts quality. The better pattern to use is to be selective. What does the model actually need to answer this specific question? Include that and nothing else. The plan as source of truth point is important. It is an agentic workflow. The written plan, not the chat history, keeps state. Chat history is ephemeral and expensive. This concept connects directly to the markdown file section, and that's the mechanism for maintaining state cleanly and efficiently. Compaction deserves a specific call out for vibe coding. When your red team coin style project session is degrading, start fresh feels like losing your work. The better technique is compaction. Ask the model to summarize the session, decisions made, current state, remaining work, and use that summary as an opening context of the new session. Claude Code does this automatically when you hit /compact. For any agent, you can instruct it. Summarize this session for handoff. What was decided, what was built, and what remains. That compressed output is your bridge into the next session. Yeah, there we go. It's touch-free.
Okay. Yeah. Well, part 3, we get to vibe coding. This is where the fundamentals pay off. Now we know how LLM work and what context is and what it matters. We can talk about vibe coding. What it is, what the hype gets right, and what what it gets dangerously wrong.
Vibe coding was coined by Andrej Karpathy in early 2025, former Tesla AI lead and co-founder of OpenAI. It resonated because it named something developers were already experiencing. The core idea is you describe what you want at an intent level and get working output. You don't write syntax. You don't Google a boilerplate. You iterate in natural language. The examples here are real and achievable. These aren't cherry-picked showcase prompts. Developers are doing this daily. The next few slides explain both why this is genuinely powerful and why it goes wrong.
In this case, you're not a passenger. You hold the architecture, infrastructure, and project management. The AI only handles implementation. Let it drive all three, and that's how you get the slop. hold the wheel and you will get leverage. Same as you would never let a junior dev design a complete system. Pick the pipeline and decide what to build.
The step reduction from 5 steps to 4 isn't the point. The difference is the cost of each step. Describing intent is fast and low friction. Googling syntax and debugging boilerplate is slow and interrupts flow. Red Team Coin is the concrete proof point. Hit the components quickly, Golang server, gRPC communications, Java GUI client, CUDA OpenGL GPU support, which is a huge thing, by the way. Real-time web dashboard, REST API, GitHub Actions, CI/CD, 158 unit tests. That's a lot of surface area. 3 weeks, 3 people, all fathers, one with a 1-year-old baby, part-time commitment, with children, being taken care of, structured AI workflow. We were able to kick it out and release it professionally, and red teams are using it to this day.
Yeah, that means that we did not spend 8 hours a day as a regular dev team would do. We were maybe 2 to 3 hours a day at max. On the weekend, maybe nothing on the week, depends. Well, the slop, that is the big problem. Is a term for AI output that looks correct, but it isn't. Let's walk through each failure mode. Hallucinating facts. The model invents API endpoints, library methods, or function names that feel right, but doesn't exist. This is a pattern completion architecture at work. In secure code, hard-coded credentials, shell injection via f-strings, the missing input validation. The model has seen insecure code in training, and it will reproduce those patterns. Then drift is another one. In long sessions, the model loses track of the original goal and starts interpolating towards generic answers. That is the concept problem from part 2 in action. And then quality degradation, a direct consequence of context fill up. The underlying case is the same for all of them. No memory, no accountability, optimizing for plausibility and correctness, and not correctness, sorry. This is not a failure of the technology, it's a failure of the workflow. Oops.
I hate it when it does this.
We got stuck. Maybe. No.
No, we don't have the talking track.
Okay.
Hold on.
We got stuck on our notes. Hold on.
How do you go back?
I don't know how you.
What's the command to go back?
We can hit over there. Yeah, we go this way.
Oh yeah, okay, all right. Hold on. We lost our talking track. We're using a web page to make it easier to pass around and stuff. Damn it.
All up there.
There we go. We're back in business. 19. There we go.
Well, this is a walkthrough of a code example. Spending time here, this is the most concrete illustration of the talk central argument, the slop version here in the screen. It works, syntactically works, even does the right thing, but there is some security gaps. OS.system, the last line, takes the target arguments as they are without validation, and is prompt for shell command injection, resulting in a very unsafe code. So let's.
The result is also discarded, so you can't do anything with it.
Right.
So you see it on the terminal screen, but it isn't stored anywhere for you to use. So the structured version, same prompt, same model, but with role plus constraints plus output format. Input is validated with a regex, no shell string, subprocess is called with a list, no injection, returns a dictionary, testable, integratable, auditable. The quote at the bottom is the key takeaway for this section. Same tool, same model, different instructions equal different risk profile. This is why the solution isn't a better model, it's a better workflow. As we can see, we have role, constraints, and output as part of the prompt.
How to write a good prompt. This seems to be a very hard thing to do. So the components are the highest leverage prompt changes you can make, and none of them require special tools or new model. Role declaration, adding you are a senior developer engineer before your question costs nothing and changes the model's register tone, and constraint awareness significantly. It is single highest return of investment prompt change. This is a very defined role, and that's why the model knows it pretty good and can act like it very quick with very minimal token usage. Step-by-step instructions, the model process number list more reliable than a prose. Identity checks, flag, output. Give the model a structure to follow, not a paragraph to interpret. It is easier for you to audit, and you can verify each step was addressed. The output format, specifying the format removes the ambiguity entirely. Output only valid JSON means that you get JSON. You can parse it, not a JSON block buried inside 3 paragraphs of commentary. The optional fourth component is the examples. Few shot prompting. You can see it there, right there. Yeah. One good example of this is the paragraph of the edge case instructions. Anthropic guidance on this explicit curates a few diverse. Canonical examples rather than you trying to emulate every rule. The key word is canonical. Choose examples that show expected pattern, not exotic edge cases.
This table makes the before-after concrete. Review this code. Gets whatever the model feels like returning that day. Role plus steps plus output schema gets something you can parse, automate, and hand to a colleague. The formula to land is role plus steps plus format equals reliable output. Write it down. It works across every tool, ChatGPT, Claude, Gemini, a fabric pattern, which we'll get in more, a Claude skill. The formula is the same, only the file format changes. This is what connects prompt engineering to the markdown files in the next section. A skill.md or a fabric system.md is just this formula written down once and reused forever.
Any questions so far?
Any questions so far?
Nothing.
Because this is, okay.
So then we're doing a good job.
So let's take a detour and answer just what is Claude or Klein. We're moving past the chatbot era and into the era of AI agents and frameworks. To understand this category, think of a large language model like the standard Claude web interface is a brain in a jar. It's incredibly smart, but it has no hands. It can't tell you how to fix a bug. It can't actually reach out and fix it for you.
It's pretty much like Futurama.
Claude CLI and Klein are the hands. They belong to a category called agentic developer tools. Instead of you copying and pasting code back and forth between a browser and your editor, these tools live directly in your command line or IDE. They don't just talk, they operate. Beyond these hands, we give harnesses like Daniel Messler's Fabric and GitHub Copilot. These act as the connective tissue. Fabric provides the structured patterns to give the AI better instructions, while Copilot provides the autocomplete flow within your daily work. Together, these tools transform a passive model into an active, integrated teammate.
Now let's look at the nervous system of this entire stack, MCP, or the Model Context Protocol, that's MCP. If you think of the LLM as a brain and Klein has hands, then MCP is the universal plug, essentially USB-C for AI. Before MCP, if you wanted your AI to see Jira tickets, search specific databases, or read your Stack messages, you had to write custom, fragile, and glue code for every single connection. It was quite messy. MCP changes the game by providing an open standard. It allows us to move from chatting to integrating, and interacting as well. When you hear people say an agent has context, this is how it happens. Instead of you manually feeding AI information, MCP allows the agent to reach output and pull exactly what it needs, when it needs it. Because it's standard, single MCP server lets one build for your company's internal documentation can now be plugged into Cloud Desktop, Klein, or the Cloud CLI simultaneously. It is the final piece of the puzzle. It takes the brain in the jar and gives it secure, high-speed connection to the entire of your digital workspace. So one more thing I want to add here is that MCP also streamlines and reduces the context used in the context window, because first it had to create a command to reach the web, sometimes inaccurately, because we already saw that it doesn't get the right API calls right, for example, and then you have to reiterate, and all this goes to the context window. With MCP server is, I know how to query this, please give me the results. And here they are, without interaction, without needing to create this web call, for example. Go on.
This is the table of an organizational chart for your digital workforce. First, you have the brain, like Claude 3.5 Sonnet. This is where the logic lives. It is the high-level consultant that understands your intent. Then you have the hands, like Klein. This is your junior engineer. It takes the orders from the brain and actually types the code, runs the tests, and manages your files. Next is the harness, like Daniel Messler's Fabric or GitHub Copilot. This is the middle management or the framework. It ensures the brain is getting the right prompts and that the work stays within the lanes of your existing workflow. And finally, you have the plug, which is the MCP. This is the infrastructure, the cables and connectors that allow the brain and the hands to see your real-world data from your calendar to your cloud servers. When you put these four together, you aren't just using an AI tool anymore. You have a complete autonomous loop that can think, act, and access your data just like a human teammate would. Now back to our regularly scheduled vibe coding talk. So there's a lot of confusion on the actual term of like Klein, Claude CLI, and these other types of agentic systems. And the best quote I have is from my friend Joris from the Microsoft AI Red team, who said, it's a harness. Agent has no definition or an infinite number of definitions depending on how you look at it.
Right.
So you'll see it interchange, calling it an agent, yet we're calling some of the stuff we're going to do later agents too. So it is a very confusing time. They haven't standardized anything yet. AI runs at pretty fast speeds.
Definitely does. This diagram is the framework of the rest of part 3. Each layer will get it on its own slide. Structured AI using isn't just about writing better prompts. It's a layered system. Agents who act, skills with capabilities, plans that what sequence, and prompts that instructs. Guardrails, which are the constraints as well. Each layer reinforces the other. Skill without a guardrail is still dangerous. A guardrail without a clear prompt is still inconsistent. The engineering analogy at the bottom of it's deliberate. This is the same principle as any mature engineering practice where methodology beats improvisation at scale.
An agent is the first layer of structure above raw prompting. It has a goal, a set of tools, and autonomy to decide how to get there. The high-level objective framing is important. You give it a destination, not every step. The agent decides which tools to call and in what order. The agentic loop is write code, test, validate, fix, iterate. Testing in that loop must be deterministic. Unit tests or manual checks. LLMs are stochastic by design, which is the same reason they struggle with math. So no model can be its own test oracle. Real tools to ground this: Claude Code, Gemini CLI, GitHub Copilot UI, and CLI, Cursor, and Windsurf. These are all agent frameworks. If you want your own infrastructure using fully open source code, you can run Klein from the CLI or as a VS Code extension and pair it with Ollama for local model hosting, which we will demonstrate later. A recommendation is to use tool-capable models large enough to produce quality code, such as GPT OSS, 120 billion tokens, billion. The risk call-out is generally important. An agent without scope limits will happily delete files, call in external APIs, or make changes outside the intended boundary, not maliciously. But it's optimizing for its goal. You must define what it can and cannot do. The fix, explicit tool permissions, scope boundaries, and defined exit conditions. This connects to guardrails, which is on the next few slides. Skills. Think of these as sub-agents, scoped specialists the current agent delegates to. Just as a senior engineer delegates a security audit to a security specialist, an agent delegates a code review to a code reviewer skill. Each skill is encapsulated, tested, and reusable. You define the behavior once in a markdown file, and the agent calls it whenever it matches a trigger phrase. Example, a code reviewer skill triggers whenever you ask for a code review. This skill contains the role, the steps, and the output format. You don't have to re-specify any of that in every prompt. Skills enforce a discipline. A skill doesn't drift or improvise. It follows the same steps every time, like a specialist who does one thing extremely well. There's a second benefit that matters for long sessions. Each subagent starts with a clean context window. It goes deep on a specific task, then returns the focus summary, typically a few hundred tokens. The orchestrating agent never sees the detail, it only sees the result. This keeps the main session's context clean and prevents context rot from compounding.
Also keep in mind that you can have several sub-agents running at the same time and producing output that are going to come asynchronously to the orchestrator. The orchestrator later will gather this information and put it together as a result. For example, if you are analyzing code, you can analyze 4, 5, 6 files at the same time and then get the results, right? Now, the plans. Plans tell the agent what to do in what order. Think of a plan as a synthesis of the task. You distill a complex goal into an explicit sequence before an agent starts working. This is critical for preventing the drift failure mode that slop slides, right? Without a plan, a long agentic task will drift. With a plan, the agent has a written sequence to follow. The example plan on the slide is the real one. You scaffold, then you build logic, then you build testing, and you iterate. That ordering matters. You don't run linter before the logic exists. Where skills enforce how much step is done, the discipline plan enforces what steps are done in what order. That is pretty much the work that you want to achieve. Together with the agent, they form a reproducible, auditable workflow. A different person using the same skill and plan gets consistent results. For vibe coding projects, that spans more than one session, like, for example, our tool, Red Team Coin. A static plan isn't enough on its own. The agent needs a way to track where it's been. The node MD, that's another file that you can use to track progress. The pattern solves this, right? It instructs the agent to maintain a running pattern, a running node that updates mid-task. Not a log, but distills state. Decision made, use our gRPC for server-client comms, the reason, latency, components affected, server, Java, client. When session ends, you restart. You inject nodes MD along Claude MD. The agent reads it, and the node continues. In what makes a multi-week vibe coding project coherent rather than repetitive. This also applies for if you're running out of tokens in your context window, you keep a log on what you've been doing, and you run a new session with this information, so you don't have to start over or catch up or tell it to see where we are at. You just keep going with your state. The code is a state, and it doesn't have to go through it again. It's in the nodes MD. You know the plan, so the plan is very well written, so it will know where to keep going after that.
Prompts, the role declaration is the single highest leverage prompt technique. Opening with, you are a senior backend engineer, narrows the model's behavior significantly compared to an unrolled prompt. The system prompt example on the side is deliberately complete. Role, task, output format. That combination, role plus task plus format, is the template.
Okay, this is the guardrails. We will walk through each layer. The prompt In the prompt itself, you can instinctively instruct the model to avoid dangerous patterns. It won't always comply, but significantly reduces the frequency. In a skill, the skill MD file is present prompt context. Once it's in there, every invocation inherits those constraints. Pre-commit hooks enforce at the commit boundary. The AI doesn't commit, you do, and the hooks enforce quality regardless of who wrote the code. Those existed prior to AI and will continue to exist. A program on the output, this is the most robust layer, programmatic scanning of AI output before it touches your code base. And the quote lands on point. Never use the eval. The guardrails are optional safety theater. They are policy enforcement, right?
This slide contains the Golang code examples that goes one level deeper in the programmatic guardrail layer, showing real patterns, not theory. This can be something that runs after the code is generated. Pattern 1, as we can see, is credential leak detection. AI will happily generate code that includes test credentials, API keys, or private keys, especially when it's scaffolding config files. Scanning the output before it hits disk catches this. Pattern 2, dangerous command blocking. When generating scripts or infrastructure code, the model can produce destructive commands that look innocuous. A block list, for the obvious ones, is a simple high-value check. Pattern 3, scope enforcement via allow listing. Validate file paths and URLs before the AI is allowed to write or call them. This is the scope limiter that prevents the agent from going off script. None of these are complex to implement. They're short functions you write once and run before any AI output is persisted or executed, typically through GitHub hooks. But you can also make like shell scripts run on the actual AI output.
Mm-hmm. Unit test enforcement is very valid for code as well. Making sure that your functions get certain value or they have certain parameters. Okay. Pre-commit hooks are enforcement at the commit gate. By the time the hook runs, the AI has finished generating, but the code hasn't been committed yet. Let's walk through this table together, each hook category, and what it catches in the context of AI-generated code specifically. Category secrets, hook detects private keys. AI will sometimes hallucinate or copy credentials into config files. This stops it before it gets into the Git history, which is really hard to eliminate or impossible at times. Category vulnerabilities. The hook go vuln check. AI suggests dependencies without knowing their vulnerability status. This catches CVEs at the point where go mod or go sum changes. The category code quality, in this case is Golang, well, what is this? Golang, CI lint, and shell check, or go vet. AI-generated code often has style violations, unsafe patterns, or shell anti-patterns. Linters enforce standards regarding of the author. So this is, sometimes you will see code that has one comment per line because the AI has been trained like that. So it's natural for it to output all these comments because they were part of their training. Therefore, logically for it to output it. Then the category correctness, the hook go unit test. If AI-generated code breaks an existing test, the commit is blocked. This is the last line of defense before history. The quote is the key framing. The AI is a contributor, not a gatekeeper. You set the commit standard and the pre-commit hooks enforce it across all contributors and human or AI.
Tests are executable specification. That framing matters. The AI-generated code that looks correct, but tests verify that it is actually correct. Let's walk through these 3 examples from a red team coin that we had. The SHA-256 test, as we see here, did the AI implement this correctly? A wrong hash algorithm looks fine at the code review, but fails verification. Context cancellation. Concurrency bugs are subtle. Did the go routine actually exit? This test proves it. Throttling under load. Did the CPU limiter hold? The test runs under load and verifies the constraint holds. Now, as we all know, we all hate unit tests, and you can have AI generate your unit tests for you, but it is very important when it's vibe coding because with the unit tests, it makes sure that it stays on track and everything works.
Still, don't trust it, check it, because if the unit test is slop, then you are creating or enforcing the slop.
Oops. The Fabric integration is the key practical takeaway. You can use AI to generate the tests themselves, pipe source code through a pattern and get a test file, then run it. The closed loop at the bottom is the deliverable. AI writes code, AI writes tests, pre-commit runs tests, commit blocked on failure. That loop catches a majority of the slop before it ships. Use AI to test AI. A test that passes is a constraint the model cannot silently violate. Part 4 makes the connection between the prompt engineering formula we just covered and how AI tools are actually configured in practice. The answer, consistently, is markdown files. And understanding that unlocks the ability to control AI behavior at the tool level, not just the prompt level.
So what is a markdown file? It's a plain text with lightweight formatting, nothing proprietary, nothing complex. The why AI tools use markdown, this is the important part. LLMs were trained on enormous amounts of markdown. They handle it more reliably than XML or JSON or custom formats. It is also human readable and Git diffable, which matters for configuration files. The key insight is the reframe. A markdown file is not documentation for human. When it's loaded into a model's context, it is an instruction set. Writing Claude MD is the same cognitive as writing a configuration file. This connects the abstract, prompt, and skills to the concrete that the tool reads automatically.
Claude.md, let's go over through this. Automatically read by Claude code at the start of every session in the project directory. This is where you put the project's coding standards, constraints, and role declaration. It is in version control. It is shared across the team. System.md, this is the Fabric pattern file. Every pattern has one. This is the actual system prompt. Role, steps, output format. Defines what the AI does and how it responds. Knowledge.md, domain context that you maintain separately from the system prompt. OWASP top 10, design patterns, common vulnerabilities. reference material the AI draws on when making decisions. Skill.md, the Claude code skill file, also in Cline too. Auto-discovered when it's in the .claude/skills directory, and also .cline directory too. Triggered by matching phrases in the user's prompt. The key insight, these files are not documentation. They are loaded into context and directly shape AI behavior. Configuration as code, specifically for AI behavior. So what is Fabric that we keep on talking about? Fabric is an open source CLI by Daniel Messler that routes content through reusable LLM patterns. Each pattern is a directory with a system.md file, the same concepts, the audience that we just learned. Red Team Coin used vibe coding for development, and the cow dog moo patterns, which was from one of the programmers for Red Team Coin, were used for quality assurance. Patterns are portable. You don't need the Fabric CLI to use them. A Fabric system.md file can be translated into a Claude skill.md or any other tool's prompt format. The key takeaway is the knowledge of writing good prompts is transferable across all tools.
Here we demonstrate the portability point from a Fabric patterns. Let's walk through the directory. Comparison, same structure, different names, same concept. Role, steps, output format in both.
The real pattern example is worth reading aloud as it shows how production quality prompt is structured. Notice the explicit identity section, numbered steps, prescriptive output instructions that prevent leakage. The key take-home, if you learn to write a good Fabric pattern, you've learned to write a good Claude skill, a good ChatGPT system prompt. The knowledge transfers. You don't need the Fabric application. This is an important permission slip. The concepts are the value. The CLI is optional.
SystemND, who the AI is and how it behaves. This changes rarely. Role, constraints, output format, knowledge MD, what the AI knows. This changes often. And new vulnerability pattern, update knowledge MD. The system prompt doesn't need to change. README.md, how a human uses the tool, triggers, phrases, expected outputs, and setup. The separation point is practical. If everything is in one file, every change requires rewriting the whole prompt and retesting everything. Separation of concerns applies here just as in software architecture. The around 2,000 words guideline is from experience. Files much longer than that starts to dilute the model's attention or any specific instruction. Close by connecting the back of the whole talk. This is 3 file patterns is behind Fabric. Behind Claude code skills, behind every production AI tool built on top of an LLM. We will review the Red Team's Coin 3 files later in this presentation as well.
Let's now walk through the skill.md structure. The front matter, name description, is how Claude discovers and triggers the skill automatically. You don't invoke it by name, you just ask for a code review, and Claude matches the trigger phrases. The steps are the same, role plus steps plus format structure from how to write a good prompt slide. The skill just packages this into a reusable file. The deployment step, 1, make dir, save the file. Claude discovers it automatically in every project because it reads the .claude skills globally. The skill on the slide is production quality. They don't need to build something more complex than this to get value from it. This skill deployed today will run on every code review that Claude asks to do from now on.
And skills or agents, you can also have them per project. Often, if you're doing multiple roles, you don't want to have skills that you're not needed or agents that you're not needed for it. Meaning everything that you add in there is going to add a few sentences, and it starts increasing your footprint in your context window as well. So just minimize the amount of skills you have, so AI doesn't have to either catalog them or list them in its memory or the context. So will work as intended.
So part six brings everything together. We've covered how LLMs work, context management, the structured framework, how to write good prompts, and markdown-based configuration. Now we look at the real project built entirely with that workflow. So you can see every concept from this talk applied in practice.
Before I keep going, any questions so far? Any topic that you guys kept thinking of?
I know this is a lot of material.
Yeah.
You said a lot about the structure that you're creating. You said a lot about the structure that we create in the folders, a lot of different files, markdown files, and how they impact on the usage of tokens and the context windows, and how we can find the sweet spot between them, because we don't want to use too much context every time that we are sending the request, and we also want that memory keeps going and we don't have to explain everything every time.
Okay.
Yeah. This is a great question. It's about basically how do you manage a large status or a big project, where is that, and how do you keep track, and how can you restart at a certain point without overloading the context. Do I get the question right? Yep. Often that is the case. It's very critical, and that's why you need a very specific plan, good design document that supports the plan, or actually it's the way around. You create the design documents, phases that you want to go through, and then you plan, let's say, if the project is really massive, I would suggest to plan over each phase and validate each phase through the plan as well. The plan should take note on what is the state of it that the AI went through. That way, you finish the session, you restart another session, and you know where to continue going. And this is where you want it to be. Often, doing a compact of the session will help you, but sometimes it is not enough. Keep in mind, too, that if you're pushing the limit on the context and you tell it to compact, you may create slop on your summary, and everything goes bad.
So a good plan will actually be able to run sub-agents, which starts a new context window in that as part of the harness that you're using. So like Claude CLI, Klein, can then kick off sub-agents, which are separate calls to the LLM, and start new context windows with what it just needs for that certain task or job as part of the main plan.
And then it doesn't overload with the context window. It overloads its own context window, and only returns the result to the context window. So there is no thinking, there is no reasoning or back and forth between the reasoning or validating, because sometimes you want to write code and validate it with the same skill set and then return what the output was. Then that code is the real one that you're going to consume, and that is returned to the project that you're writing. So that is what you try to achieve with this. But again, you need to keep
That's
a
why
good track
the
and a
steps.
to-do list of where am I at, where I am at, and what is the next step, right? Often diverts a little bit because it's like, okay, I want unit test this, and it wasn't in the plan. So you may need to alter the plan to do that, or just do it ad hoc, but it must be documented. Otherwise, may step into the next step or another step from a different.
Yeah, sometimes it's
plan.
good to update the plan and throw away everything that it generated. If you have a company that has infinite tokens, and just regenerate it again. It's some of the thing I did on my previous job. Quite a bit of time just to make sure it generated clean code.
Yeah.
The CEO said unlimited tokens.
Okay. That's yeah.
Each component in this table represents a real implementation decision that required AI to produce the correct, secure, testable output. For the Red Team Coin crypto mining simulator, Go plus gRPC, protocol buffer definitions, server client implementation, and reflection, Java GUI client. Swing GUI with headless mode, concurrent miner threads, CUDA OpenCL GPU support, kernel code for 2 different GPU APIs, web dashboard, real-time WebSocket updates, chart rendering, Bear Token REST API, authentication middleware, endpoint design, GitHub Actions CI/CD, matrix builds, cross-platform artifacts, quality gates, 5 pre-commit hook categories running on every commit, 158 unit tests covering hash correctness, concurrency, throttling auth. All of this went into the plan. This wasn't built by throwing unstructured prompts at an AI. Each piece followed a structured workflow from part 3. The question is not whether AI can build this, it's whether you direct it well enough.
Okay, 5 things to remember. Pattern completion engine, it's not an oracle. Calibrate trust. Use it for speed. Verify for correctness. Number 2, vibe coding speed is real. Unstructured use produces slop. The framework, agent skills, plans, prompts, guardrails. This is the structured AI usage model. Markdown files, CloudMD, SystemMD, SkillMD. Is a configuration as code for AI behavior. 5, context is a finite attention budget, not a dump space. The principle from context engineering applies directly to vibe coding. Find the smallest set of high signal tokens that maximizes the likelihood of your desired outcome. Context rot is architecturally inevitable. So be intentional about every file you attach, every log you paste, even turn off a history of to carry forward. For example, for logs, you don't need to paste the whole log. You sometimes need to paste one line before it or one line after, just to give it a little context of what the error is. It's the same as you would Google up, right? You won't Google the whole file. You're interested in what failed, how it failed. So that's what you paste.
So from asking questions to direct AI workflows, that mental model shift is what separates developers who get consistent value from AI from those who get inconsistent results. So we're going to try a demonstration.
Yeah.
You ready?
We'll see. Yeah.
Get ready.
Okay. Anybody? Should we do a break for everybody?
Yeah. Does anybody need a
Washroom
break? No, we can keep on going.
Yeah.
Okay. All right. While he gets set up, anybody want any stickers? Stickers? There you go. 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 There you go.
I'll be bringing things here in a moment. To the right or to the left? This is not gonna be very quick. It's gonna take a while because we're gonna try to create an application that calculates the pi digits, massive amount of pi digits. We're not happy with just 6. We're targeting thousands. I don't know what's the purpose of that, but that's fun. And yeah, now the calculations are in the trillion. The method that I am targeting, or that we will be targeting, is the Chetnovsky method. It's based on Ramanujan calculations, and it's pretty effective on iteration. So you may not get the last 5 numbers correct, but the rest is. We will try a very structured way, the way that we should be doing this, with agents, with plan, with design doc, with everything. And I'm going to demonstrate here. Here we have the design doc. Ignore, well, it's what it is. The phase implementation, the plan, and here you will see that GitHub.
We can't hear you if you're just talking.
Yeah, you need the mic.
Oh, right.
Yeah, yeah.
Okay.
If you want to hand off the lab.
Yeah, I can hand off the lab. Can you zoom in a little bit too, because no one can see that.
Okay.
Just get this. Yeah, clip that in there, sure.
Okay. So, quick recap. We're gonna do pi calculation, very long numbers, very long digits, such as the thousand, hundreds, or hopefully 10,000, if my machine allows. Here is the very digested. I created all this to speed up the demonstration. We get a design doc, phased implementation, a plan, and you can see a GitHub location there. We're going to use a GitHub Copilot, so it's a
So let's start by
CLI.
looking at the plan.md. That's the main file, right?
Right.
That's your system MD.
Well, the design is the main file. The plan is to execute the phase implementation of the design.
Let's go to.
But I want to show the skills and other tasks that this GitHub may have. So, okay. So what is it inside here? This is a context just for this project. And we have agents, skills, workflows, everything, right? But let's dive into skills. And here are the skills that I previously created for this senior dev orchestrator. C++, which is the tools that we're going to use today. It also does C#, Python, and the skills are spread into 3 main categories: development, documentation, and research.
Let's take a look at a skill really quickly.
At one, okay.
Yeah, let's look at one
So-
just to see the format of it.
Yeah. So, okay. For that, I'll do this. It's a lot easier. CPP documentation. Which one do you guys pick? Okay, let's go to the first. Development, if I correct. So this is it. This is the whole skill, right? Not very much, but it does have a clear description, a clear name of the skill, and these are the guidelines. The agent, we have one agent for this, is the senior dev orchestrator agent I mentioned. And let's take a quick look at it. It's a lot more complex, right? But same in the same format. You still have its name, a description, and below it's
Role.
it's what it does.
Steps, and then the output that we're expecting.
Yeah, and some samples as well, right? But this is to keep it in a guardrail, right? Your prompts. Also, which skills it's going to use, it's going to also keep it in a guardrail, so to not deviate for other skills I have in the system. So the design doc is going to be a lot more complex. Let's dive into it. You see, it's a lot of text. This is like a dev doc, right? And it does reference here. It does say the Chesnovsky method and the GMP and MPFR are the libraries that are going to supposedly be used to target a floating point number that is huge and will not be a 16 or 64-bit enough, right? So phase implementation, you want phases for this because might get very complicated. And here they are, just different stages. We're not going to go through all of them. We're going to just make it work. But this algorithm can have some parallelization to speed up the calculations.
So as you can see, as using AI, you tend to turn into the actual software architect, and the AI turns into your programmer.
Do you use AI to help produce this at all?
You can, yes.
Definitely.
Yes, definitely, 100%.
This was done with
Yep.
AI.
Yep.
I have a PM skill as well that helps with this.
Make sure you read everything.
Yeah.
It's
And
very important you read when you're creating plans. Read everything and make sure you agree with it.
also the skills, the agents, because that is really what has the guardrails and may produce your work. So you may need to enforce that those do the job. You can use also AI to rethink it, add comments to it. It's pretty rough on that, so it might give you a good context. Sometimes you dismiss what it says, but you have to keep it on track of what it produces. Yes.
It looks like a lot of work. It is. It has to be, and especially for big projects. Is there like a template or something that we can reuse for other projects or other things, so we don't have to go over this every single time that we want to use it? Do you think like there is a pattern or a template that we can produce for big projects like that?
Correct. So if I understand the question correctly, is do you have all of this is a lot of work, which I agree. It took me a couple hours just to create the agent and the skills. But I can reuse those. I can reuse those in any single code project that I want. The design is fixed to the projects. You cannot really mitigate or transform or anything. But all the skills and the agents, you can reuse in every single
that's
project.
the big thing.
If you create one for code scanning, especially for Red Team, if you get hold of source code, it becomes your tool to scan code, create POCs, and enumerate and possibly create a report as well that you can hand off. And you can do that with many projects, right? So you build it once, and it stays with you, right? Usually to create an agent, you should create them the most generic as possible and have the skills the most targeted as possible, right?
Yeah, later we'll go through the red team coin markdown files, and we'll also go through the skills that we actually used, or the fabric patterns, because we were putting it into the build pipeline and stuff to fix code and do other things that we created for the project, mostly Jason Grace.
So I type agent, I'm gonna select I have several ones there. And we're gonna select the senior dev orchestrator for model. That's the other thing you should select. I was using GPT Mini, but you wanted to use Claude?
No, we can use GPT Mini.
Yeah.
Yeah.
And this is it. We're kind of ready to start. So I curated a prompt that is not rocket science, but helps me out typing in this moment. Let's see. Paste. No, didn't work. Okay.
So let's explain this. As you can see, he's referencing the plan, and then he references the markdown file for the phased implementation, and then he has the design. And even though he misspelled please, it'll still recognize it and work because AI is awesome.
And I also put thank you at the end, just when the machines will take over the world, they say, oh, he was a good guy, you know. He always said thank you, but anyways. Yeah, so you can see here that it already knows the files, and yeah, hopefully it's gonna be good. Let's start. So it's thinking. Okay, it's a lot of thinking in this project. It's gonna be a lot of thinking.
This is where you use the plugin that loads up Instagram, Reddit, and other things, and it pings you when it's finished.
Yeah.
You got to get the brain rot in while this is the AI is working.
There you go. Ah, good.
Okay, you want to explain what's going on here?
So right now it picked up that it needs to read the plan, the phased implementation, and the design documents. And here it is what it's doing. And then it's starting phase 0 right now. Phase 0 was the first. So here it is thinking, and now we get now we get recommendations how to proceed.
And this is the human in the loop aspect of it to kind of keep it in check. So
yeah, let's do this.
With Klein, you can shut that off and just have it do wacky stuff.
I try not to, but yeah. You can also here. To get a better interaction, you just have to specify it. Otherwise, it will do what it wants or what it thinks is correct, right? So I add. If you have any questions, I'll add clarity and guidance. So there it is, starting to do stuff. Okay, now it's telling me what to do. So I'll have to reply with this. slide. You can also say yes, confirm.
And this is why we need more AI data centers. So
Thinking. Yeah, it's a lot of idle time on our end, so that enhances humanity to do more, right? Once the project is further ahead, we can also see what it did, how it did it, review it manually while it's working. So for now, there is not a lot to do. Okay, it's good. Yeah, this SQL, it's all over the place. It's usually what. This is a sample of what it wants to add. Yeah, this seems correct. This seems correct. Okay, continue. I'm also going to show you what I did with this. Like I had a previous test, which I ran it and created the executable. In case this is taking too long, I can shortcut that way. But I have two examples. One that doesn't calculate it very well, and another one that is dead accurate. I was surprised on that one. But let's dive into it. More zoom. This is a good one. And for example, see here are all the big code. Okay, now it's more color, nice. I did instruct the skill to write it like this with very minimal comments, and you can see it does that. You barely see a comment, only if it's really needed. Let's see another. Yeah, this one will have more. This is the actual calculation from this other example I had. Let's check in the meantime how is this tool doing. Okay. Oh, started creating things. Okay, let's leave it thinking, and let's keep going. This is very relevant. It's the actual calculation, and that's why it's there. And here is the implementation. More reinforcement that it does comment, but really when it's relevant, rather than in every line or every few lines. That is key too, because it saves you on tokens when you're reviewing the code, when you are maintaining it, even when you are reading it, you don't need to read something that
Let's see the
there.
unit tests.
So here are the tests. I never seen this, so let's see. Okay. So it's doing unit tests of very specific parts of the calculation. So it's in one iteration, and it's expecting this or that, and that's what it is. And let's see the other unit test. The big int, that's it. Okay. So you need to have, I don't remember exactly the implementation, but this is for the library that handles the amount of numbers that it can handle. And it's built here. It's all over the place, but this is the real application. Let's do less than that. 1,000 digits. Oh no, let's do a little bit less. 100 for now. There you go. But the question is, do we believe it? Do we believe it or not?
Trust but verify.
Exactly.
Trust verify.
So we copy, and let's see. Let's bring this here.
Correct.
100%.
There we go.
100 numbers, right? This is created with it, but we will get there. We will get there. Let's do 1,000.
That's 10,000.
No, this is 1,000. Well, yeah, this is 10,000. Okay, it's good. It's good. Let's see if it's not luck.
10,000 correct.
More? In the meantime, let's check how our
let's go,
puppy is doing. Okay, what the puppy says. Yeah, go ahead, do that. Yeah. Why not?
Look at those tokens rise.
Oops. Context. So we're good. 20%, right? It's a good spot. I don't know if it's a bug or not, but it's more than 160K. So if somebody knows somebody in Microsoft should fix it. There are other models with also this is fixed, and it's well known that they do more than that. But it's okay. It's a general check. We want to know that it's good.
So going back to your prompts, which one was the system, which one was the knowledge, which one was the notes?
I don't think there is notes for this project,
Okay.
but it's pretty. I mean, it's
But your
very
design
small.
doc is the knowledge.
The design will
Yeah.
be the knowledge. The face will be somewhat the stage.
plan, yeah.
The plan is there to
Yeah.
execute everything, but it will loop through the different stages. You can do that, but you want to have, in a very large project, you want to know at which stage of what phase you are at. And then in a case that the session gets disconnected or not, it just, you look at it, you look it up, and you can continue from there. So where are we at now? Concerns. Yeah, we did 10,000 in that page that validates that there was a limit of, I think, 20,000. So we can go 30,000, and it's gonna do 60% is correct. The rest is not. Well, you just don't have the rest. But yeah, it's how much pie you can get. 10,000 numbers, I think it's more than enough for your calculator. And yeah. Anyways, let's see where we get from here. So it is building something. So let's try to see what is it building. No, it's not building it. Main. So Bit also has, you made a configuration that with client that runs locally.
Yes, yes. First of all, let's take some questions. Does anybody have any questions at all about what you've seen so far? I know this is like a garden hose of information. We can go into some of the red team coin stuff if you want to pull up red team coin. Actually, if you want to pull up the cowdog move fabric patterns, we can talk about those that we use to help as part of the guardrails.
I don't have it on disk, but I can pull it out of
Yeah, just web browsers.
where it opens.
So currently, we'll be moving away from Fabric into something new that will be released soon. I can't really talk about it yet.
And our favorite is Kaido Wu, right?
Yeah. Yep, and then go to
Fabric, was it?
Fabric patterns hub or something. Fabric patterns hub right there.
This.
Yep. Okay, click on that. Okay, so this is what Jason Grace put together. Go to patterns. And you don't actually have to have the fabric loaded. You can use these patterns directly by just referencing the system.md. So let's go to Go Review. So this is one of the things that we use to control the AI when we were writing that. Here's the README file that tells you exactly how to use it. And then if we take a look at the system.md, you'll actually show the actual things. So you can see identity and purpose. You are an expert Go code reviewer with deep knowledge of blah, blah, blah. That is the role. And then we have the knowledge base, which actually references, this is a knowledge.md type file. That is the Go review criteria.md. As you can see, it references it. If you scroll down, then it has the steps, which are the actions that it's going to take. So it definitely does that. And then we have the output here that it gives us the, with a reference of another knowledge type file and stuff. And then it gives, and then how we do the output instructions and here and stuff. So this was something that would run on all code generated to make sure that it was following the proper things for proper Go coding and stuff. So this was using as a guardrail to keep the AI in check so it doesn't do any slop per se and would flag stuff. If we go to another pattern, just, yeah, go up to patterns, yeah. And let's pick the Go doc comments. This was, and let's go to right directly to system.md. So here we go. You are an expert code documentation specialist. This is what we use to do the documentation of all the functions in Go to make sure that it was correctly documented and in readable English that we could easily follow. As you can see, we have the knowledge base again. Scroll down. And we have the steps. And we have examples in some of the documentation type stuff, how to do comments in the code and the output format and what the documented code should look like. And if you actually go to the Red Team Coin GitHub, you will see these well-documented functions for all the Go code. There's also a unit test one. If you go to patterns again, you will see, scroll down, Go tests, that's the one. There's also some Python ones. If you go to Go tests, there we go. And if we go to system.md, you'll see that, again, this does the test suites to create the unit tests. So this was very important that with several people using and submitting code together, like what Luciano showed you was just like one person, one agent / harness, whatever, using it. We had 3 people with multiple different AI LLMs and harnesses going into the same code base. And some of these things were like having unit tests. So one person submitting code won't break the other person because it would like this stuff. In the beginning, when we were doing raw prompting and stuff, a lot of times it would take the we're running a web server. The AI just automatically determined that it's most efficient to run it on localhost instead of all ports. So now nothing can communicate with it because it's running on localhost. And there were times where we would put it on all ports, and then I did something with raw prompting, and then it would just automatically say, hey, it's easier if it was on localhost.
And it just reverses
It just
it
breaks
back.
everything. So like having those unit tests in place to test, is this available on all ports? You know, which the AI automatically put in there. It would then say, yes, this does not meet the things that we put into the Git hooks that would run these tests
Right.
when we submit code. So nope, this breaks it. It doesn't pass the unit tests and stuff. And there's even a pattern for the like CI/CD pipelines. I know this is very dev focused, but this can be easily translated into offensive security. But due to the streaming of this, we're keeping that. PR for submitting PR requests. If we take a look.
So also keep in mind the structure, right? It's like identity and purpose and knowledge or steps. It's very important to have the sequence, right? And then in the end, how do you want it to be output? Yeah, in this case, it's no code blocks or markdown faces, but it all depends the application of it. If you are, for example, enumerating vulnerabilities, you may want them to be in a JSON format.
There's a pattern for that. Go to patterns. Go to Go security audit.
There you go. And this also is very specific to Go. So
There's a Python one in here too.
Right.
Oh, no, there isn't yet.
But
I'm going to submit one soon,
but this is very specific to Go, and you want sometimes to be specific to a topic,
yes.
right? Because
This is the big mistake that I see tons of security people doing because they think they have a huge context window. They just dump an entire repository in there through like repo mix or some other BS, and then ask it to blank, like give it a blank check to go or whatever, and it's just going to produce the most slop possible and stuff. This is very specific. It has certain common vulnerabilities. It's to a specific language, and if you scroll down, you will see the steps are very, analyze input code, run vulnerability classification, categorize findings by severity.
right.
This is good at like small code bases, but you can break it up to like only do like certain sections of it. Or at my previous job, we did where we would create like mermaid diagrams of the code flow. And in the mermaid diagrams, we would have line numbers and files. And from there, we're saying, okay, well, these parts might have these types of vulnerabilities on it, and then we can have the structured skill or prompt go and look for those specific things in the code base without like ingesting massive amounts of it. That was some of the like agentic ways that, it was able to like find vulnerabilities and other things that could be exploited, especially some like use cases like business logic vulns and stuff that could be chained together and stuff. So how's it running? We got our application yet?
Almost. We will get an executable.
Is there any questions at all? Does anybody?
What do you think?
Whoa, take the mic. We're streaming this.
So you've built up your experience and become senior. What do you think are the odds that someone graduating now and leveraging these tools and techniques, like what are the odds they're going to be able to not produce slop?
So if I get the question right, is what are the odds of new, inexperience or fresh out of school graduates that try to use these tools and create slop?
No, well, sort of. Like, the end goal is not to produce slop, but do you think that there's going to be, like, do you think that they can practice this tool and become proficient at this tool without going the long path of not using the tool and learning to become a senior dev without the tool?
Mm-hmm. I mean,
So here's the deal. This is what my experience. God, I wish Yoris was here. What we've seen is that AI can take a junior dev and make them like a moderate level dev, and a moderate level dev can get a little bit better, but I don't see AI replacing senior level devs. The ability to look at stuff, I don't think that. And I think that we might see some brain rot from some people that are relying on AI too heavily. But we saw the similar thing with calculators.
yeah, and I don't know. We have to also know that, or reflect back, and when computers started, people used to program in machine language on cards. And then assembler came over and made waves because he didn't have to rely on those cards anymore. And so on until we got very advanced programming languages. And every time that one of those huge lapses happen, there are even more jobs and more demand. It's just the discipline changes drastically. Instead of remembering codes to call functions, you do it with words like if, right? Instead of CMP and then do opcodes.
But as an industry, I know we're seeing a lot of layoffs over the AI stuff.
Right.
I'm being a victim of one of them, where the previous employer I was at decided to lay off 40% of their property employees. I do see that probably we'll see a number of hires coming back, especially due to how expensive AI is. So they'll say, okay, so we really do need people, and we'll probably see another hiring cycle and stuff. Yes.
I was just going to follow up to what he says. It feels like the people that can have the most power would be architects that haven't coded in a while, but they understand the system end to end, because now they know what they're doing. They can recognize flop. They may be not a strong coder, but that's what AI can do with the right instruction.
Correct. Yes.
You are 100% correct. With AI, you become the architect, and the AI becomes your coder, as long as you're very specific about your architecture diagram or the specific on your instructions. He actually architected the program in Markdown files, and now the AI is actually doing the programming of it.
Right. So something else to add is, like, I have no previous experience with Go, and I still don't. I mean, and we wrote a tool that is written in Go. And what about the CUDA? Yeah, that's
Fully works with tested GitHub Actions, builds everything, lets it up and running. You will see currently on the project right now that GitHub Actions is failing, but that's because we got rid of the Windows 10 machine we were using to test the Windows build.
Right, but
Everything else builds, tests it, works. We got CUDA and OpenCL.
yeah. Okay, maybe the only line that I touched was to a binding of
That was the local host thing,
of the local host.
which you were kept on yelling at me about.
Yeah, and then you yell at me, but it's okay. But that happened. But we did this without touching source code at all. And okay, it's a bunch of yes and hitting enter so far. So So what it's doing now here is trying to compile it and see it fails. So that's also a check. And it's also fixing the code so it doesn't happen again.
This is where the agent/harness comes into play, that it can do these and get the output, where if you have like the chat interface, the chat window days are, long gone.
First, we want unit testing. Although it told me, it's like, why don't you do the Chudnovsky implementation? It's like, well, let's make sure what we've done so far is what we've done so far. So it's starting to do this, and we'll figure it out. Apply changes, confirm is what you want. I'm not sure why it always asks me this. This is not the first time. It should be the dialogue, but we will just go with it.
I think there is a way to do apply change always yes.
Yeah, but at times you want to decide which one do you want. Like here, you see, like trust it blindly, but that's what we're not doing today. I could do that, but that might drift the output, and I don't want, like, I wanted to do specifically unit testing rather than the implementation of the algorithm. So Google has a platform for testing. That's why you don't have to write a lot of testing. This is actually the unit test for it, for this begin library. And that's about it. Okay. Anyways, do you want to check on... We were in the fabric patterns, but well, that's cooking. Let's try the.
You want to go to Red Team Coin?
Yeah.
And take a look at some of the AI output from it.
Let's see if it shows up. Wow.
Yeah, there we go.
You go.
So let's go into some of the fun stuff of.
Yeah, that's WebAsm, WASM as well. That's pretty cool.
Let's go to scroll down. Let's take a look at our GitHub Actions. Oh, let's look at the pre-commit hook config that we have.
Is this? I'm breaking my neck to see that.
I think so. Yeah.
Yeah, pre-commit config.
Yep.
Okay, here it is.
We had the YAML lint, code spell, pre-commit Golang. What else do we have? We had sure shell script, markdown lint. Man, that was annoying. Some of the Go replacement, the Go unit tests.
Yeah.
Golang CLI, lint, the Go vet.
Yeah, here's the unit test.
Yeah.
Go vet. Yeah.
Go license prettier, Go releaser check, Go vuln check, scan. And let's go into, where's the GitHub Actions?
Maybe in config, I didn't do that part, so.
Might be in there. Where do we have GitHub Actions? Actions, there we go.
This?
So we, so these were actually designed by the AI and sometimes modified for the GPU mining stuff was kind of a thing. But a lot of this was written by the AI prompts. Well, the patterns that we had to create these build things for the GitHub Actions.
Okay, let's jump again to our beloved code. Here, yes. Okay. Let's leave it thinking for a while. So yeah, this is the actions, and there were some workflows as well.
Yep, we had some workflows. Go releaser, GPU CUDA build.
The pre-commit. This made us cry a lot.
Yes.
Yeah. And yeah, this is open to everybody. Everybody can download it and run it.
Why did this make you cry a lot?
Often, well, because you didn't code it yourself, thinking what or how to produce the code. It will, AI will give you some code that is not up to standard with the pre-commit, such as naming convention, an extra space on a markdown file, all these things.
And our guardrails were like, nope, go back,
Right.
redo it.
But what you get in the end is a consistency throughout all the files, modifications, and you don't have a function looking one way and another one in another way, comments all over the place. No, you have a very structured file, and this keeps in line 3 people who want to do whatever they want.
Yeah.
Because it's not just AI that wants to do whatever they want.
So having rugged guardrails are very important in AI,
Right.
especially in development. And sometimes you got to do that with classic things like pre-commit hooks and other just standard dev practices and stuff. We're boosting.
Without boost fallbacks, yeah, that's fine. Maybe I don't have that installed.
So while we're doing this, I'm going to pull up my Mac and show you what it's like to run a model locally.
Yeah.
Pull down dependencies off the internet automatically?
In which way?
Like if it's using, I'm assuming Boost is an external library, right?
So, okay, so the question is if it pulls down the dependencies automatically. And I responded in which way. So the short answer is yes. It will suggest to pull them automatically, and how to pull it. Same way that is doing this build. It's not native to the AI. It's a external application call, like anything else. But it will suggest to do things such as apt get something, or call a container specific. What is this? A specific build of a container for it if it needs to. Yeah, it does it. You just need to make sure that's what you want, because it will just suggest whatever it thinks it's good or is best. Do you want to pass here?
Yeah,
Yeah.
I'll take
Okay.
over while you finish
Okay.
that.
I'm gonna hold this over there, and so we keep it running, and then I pass the command to him, so we can. Yeah. Okay.
All right, sorry for the AV people running things.
Gotta hold the mic.
Okay, so let's talk about a few things. Let's say you can't afford Claude Code or GitHub Copilot or any of the other things. You can actually run models locally. And I'm using an open source model called, it is a Chinese model. It is called Qinwen, and it stands for 1,000 Questions. That's the name of the company. Stop Asian Hate. You can use something called Olama, which is really easy to install. And as you can see, this is hosting a model. And it's this one just came out Thursday of last week, which was pretty awesome. And you can send it prompts directly. As you can see, I am asking it. I'm asking it in Chinese. I like Qianwen. And this is sending the prompt directly to it. And then it will load the model onto my local machine into the RAM and the GPUs limited for this machine. And it will respond with that. I can also use English too to get a response, but I think it's more funnier to do this way. Don't ask me to read it. My Chinese is terrible. So you can then configure Klein to use a local model, which I have right here. And you can ask it stuff like, of course, this is a bad prompt, so let's make this into a good prompt. So as you can see, it is now, will be acting. It is contacting the local model that I'm running here. That's for coding. We will then see the steps that it goes through and its stuff. It does take a little time to load the model, although I did preload it by telling it that I really like 1,000 questions. And so now it's loaded in memory, and it will now communicate with it. So this is a MacBook Pro with 64 gigs of RAM. It is not the best for running models per se. A few friends of mine actually have like NVIDIA Sparks, DGX Sparks that they have. They're like 3,500. Some of them have like some video cards that they run off of, but a lot of my friends that are consultant red teamers, they have a stack of DGX Sparks that they use and stuff with some open source models and prompting and stuff for backing up their red team stuff. So as you can see, it is basically telling us what it is in here. This project is called Sample Slice. It is something that I'm building to basically be able to automatically edit WAV files, slice them up, and then write a file format for a synthesizer that came out in 1992. So first of all, I built this in Go. How did I do this? I had to use a lot of prompts that I wrote to pull in data sources. As we can see here, I pulled in some PDFs. I pulled in some previous projects that people had done, written in Python. And then I made different README files that, or markdown files of the information format that would look like what does a .krz format design look for. So it went through PDFs and people's previous code to basically harvest that information and put this into a knowledge.md type file, as you can see here, that kind of lays it out. And from there, I also went into some of the programming elements of it. I made this a separate file, but remember we said make sure that things are specific and to the point, and that's why I had separate knowledge files for the different aspects of it. As you can see, I get into the program structure and other things. This was all harvested using AI. This was all done in the local model too. I did not use Claude or anything else, so this is all stuff running on this Mac. So it is possible to do that running locally. It doesn't work as well as a GPU farm that you can get access to. Thank you, CoreWeave. But this does have stuff. It also, here's another one for a drum plan and stuff. And from there, I put together a plan. And this one is pretty terrible. I'm probably going to delete all the code and rewrite this plan. But as we can see, there's the tech stack, project structure, core modules. This also generated WAV files for another synthesizer that I have, the Akai MPC. So I actually added in the Kurzweil specification to this. Again, these Akai is a more modern thing, so it was easier to get stuff, but I added the esoteric synthesizer too that came out in 1992, even though the documentation, yes?
You might take a step back and tell us how did you set it up the first time, the local model?
Okay, so what I did was I used, now before, a lot of people would, people would have to write individual Python programs, and that was it in the chat interface era and stuff. Now there are platforms that run LLM models. One of the software packages is called Ollama. That is the one I'm currently using. That's Ollama, and you can type do list, and these are the models that I have on the machine, and you can do you can tell it like different ones it's running. So you can see I'm using coding 16K. Don't ask me where I got that from.
So the Ollama, it's a very easy to install platform. It's almost platform agnostic. They have support for all sorts of hardware, including AMD hardware. You just go ollama.com and they give you based on your platform.
Instructions. Yeah, it's very simple to install.
The client, look at it as it's very close to what Claude Code is, or GitHub Copilot is, that you can run it as a plugin on a Visual Studio Code, similar application, or you can run it as a CLI as well, like in this case he is. Yeah. But it's also open source. So why he's using that is to show that if you want to go fully open source, you can go this route as well.
It even does skills too.
Right.
Which is really nice. These are,
correct.
If you notice, those skills are the similar ones that...
And an agent does all of it.
It does pretty much almost everything that Claude CLI does on a local running thing. So as you can see, you can totally run this, and you can produce all this crazy code with that I coded using that, the go mod, go sub. I think there's the main.go. The CMD, where's the CMD? I'm in the middle of still developing this, and I wanted to show you that you can do completely local development for it. Where is, oh, it's up here. CMD. Root.go. All of this was AI generated from the architectural plans that I have. So any questions about the setup at all, or?
Yeah, I have a follow-up question, actually. If you take something
The
open
mic, the mic.
source-
Oh, no, well, yes, yeah. There we go.
If you take something open source that you don't know where it comes from and you start running it locally to generate your own code, how do you protect yourself from the model having malicious input or anything like that?
Guardrails.
Well, so the
you speak
question
about
is the question is how do you protect from a model that has potentially been loaded with malware?
Oh, yeah.
Well, that is really, really hard. There's been studies that are quite inconclusive on how to detect them. There are many, because the files are so huge, it's very easy to do stenography and do not, even with the stenography in there, with the bits altered, the output might be still relevant and good. So the model might behave properly, but it might do what the attacker wanted to.
It's pretty hard to do.
The best ways is to download things like you normally would from a trusted source. You won't download something from something that you completely don't know or don't trust, or you don't know the sources, right? It's quite difficult to test. There are some companies that do this type of work to try to understand if there are hidden malware in the source code or hidden malware in the models, but it's many layers. It could be altered so it injects bogus code or backdoors, or it could also be that it contains backdoors when you query for something specific. It's very hard to identify.
But typically you put in guardrails in place to recognize malicious code that it generates and other types of stuff.
Right.
That and anyways, actually baking in, to generate like vulnerability, to generate like malicious stuff in certain prompts is very hard to do. So, I mean, maybe nation states can do it, but I haven't read a paper where somebody was able to successfully do that on a large language model or discover anything per se from that. And most of the time that when it does actually people say it was ingested during the training phase from a bad code example is typically from what I've seen.
Does that happen too?
Yeah.
Are these models I don't know. So when you're running this using Olama, is it pulling stuff from, is Olama hosting the model, or is this
Yes.
from Hugging Face or something? Do we know what is it like pickle files or safe tensors? Those are terms I'm familiar with.
Goof.
Right.
So the question is, how do you download stuff for Olama?
So yeah, this is from Hugging Face. Yes.
Okay.
So yeah, Olama does offer their models tuned to their format, but they also support GUFF
Yes,
format,
which is a safer.
which is in Hugging Face.
So
right?
you can't do the pickle attack like you can usually do.
Right.
Yeah.
Yeah. It won't work, the pickle attack.
Got it.
Pickle would be like you can pack anything in there.
Right.
Yeah.
Running code on your box.
Exactly,
anything.
exactly. Which is a lot of the wackier models that you see on Hugging Face
Right.
could have the pickle attack, but this is proper GUFF, and Olama prides itself on making sure that the models it expects and stuff. And it's like a simple way to load a new model. I think you do Olama download or something. I might have it. Yeah, it's like Olama download, and then you specify the model that you want to download, and they pull it from Hugging Face.
Yeah. So this is again, Olama also supports to connect to cloud environments or cloud models, but it's not the case for this example. This example is to run it locally.
Yeah.
Yeah, the different models will act differently, and although they are all based on the same algorithms or techniques, which is the transformers in this case, because it's mostly text, training data makes the difference with the weights. So you're basically going after those. And the larger the model, the more capable in theory. And also keep also in mind, this is quite interesting too, but a model that can do a very few, that has a lesser parameters may do lesser complex stuff, right? And in theory, or in practice, actually not in theory, you want to create some good code. You want at least to pay something and get the 600, 700 billion models usage rather than running your own, unless you can run that huge of a model.
So to wrap it up, I'm Peter Grigo. I am available for hire. I currently unemployed and live with my mom. And Luciano is linked in there. I want to space thank you to Jason Grace, our third person for the Red Team coin, who helped us think agentically, and were able to write this whole workshop. Joris of the Microsoft AI Red Team for input, and Dr. Minich of the AI Red Team for dealing with our stupid AI questions on all times of night and tying up her husband while he was having some baby issues and taking it out on us.
All right.
And that's it. If you want to continue demoing that, that's pretty much the end of our workshop. Oh, yes. Yep, go ahead.
Hey, so it's Kyle Fox here to let you know that this is a DC 206 talk hosted by Black Lodge. Please donate to Black Lodge if you like this talk or want to see more like it, so we are able to afford the annoying rent here in Redmond. As you can understand, rent is going up for all the hack spaces, and we're trying to get more people donating and more people just generally like vibing with us and donate and whatnot. And we also open hack nights on Thursdays, starting about 7-ish p.m. Sometimes it's open before then. Very rarely it's open after then. And then we usually conclude sometime around midnight, or at least tell people to fuck off at midnight. So, yeah. Welcome to Black Lodge. If you want to have a look around after this talk is over, just if you want a tour, let one of the Black Lodge members know, and we can give you a tour. So, thank you.
I'll hand this over. And,
those of us who want to see the pi calculator,
How is it going? It's around here. Hold on. This should fit.
Also, we were recording this, and it will be probably posted on YouTube at some point. I can't make any promises on when, because I'm sure Zach is hearing this, and you should post the last one. But yeah.
if anybody wants the vibe code right now, we will assist you with what you learned here today. Also, if you want more stickers, just let me know. I can give you more.
Since they moved here, yes. I think for post-TC barbecue.
So, for those new to this space, this is the workshop.
Thanks for the talk. It's great.
Thank you, Joy. Thank you.